Hello class, this is a recording for our next example in section 3.4. Now let's change it to example 6 if it's not already, okay? Example 6, A, find the rate of change of the area of a circle, let's call it A, with respect to its radius R. So what do you guys remember about the area formula of a circle? Area of a circle, what's the formula? Do you guys remember? Area equals what? Pi r square, okay, which they said let's just use A for area. Now it wants us to find the rate of change of the area of a circle. Well, rate of change is the derivative with respect to radius. So remember, pi is a constant, so I don't have to do anything with a constant, but I'm going to bring down power of 2 times r. So the rate of change of the area with respect to radius is really 2 pi r. Oh my. Look at that formula, 2 pi r. What does that look like? 2 pi r. 2 pi r. What? That looks like a formula of something, right? What formula do you think that is? What formula do you think that is? What? You said what? The derivative of the area is the circumference? Crazy, right? Totally crazy. Okay? That is the circumference, right? B, evaluate the rate of change of A when the radius is 5 and when the radius is 10, okay? So that means evaluate the rate of change. You already found the rate of change, which is A prime of R equals 2 pi R. So it wants you to evaluate at A equals 5 and at A prime equals 10. I'm sorry, A prime equals 5 and A prime of 10. Now let's plug it in. 2 pi times 5, which is really 10 pi, right? Now let's write in the unit of measurement. This is the change, right, with respect to radius. So normally if this is talking about like feet per second, then you write feet per second. Well, this is a change in area with respect to radius. So 10 pi area unit, okay, for each radius unit, okay? So every one radius unit, the area is going to increase it 10 pi, okay? So this one I'm going to plug in 10 now. So 2 pi times 10, which is going to be 20 pi. Now let's write the unit of measurement, area unit for each radius unit, okay? Area unit for each radius unit, okay? So that's how you write the unit of measurement. It's always the rise over run, okay? Rise is normally talking about the y. So in this case, your output is the derivative, which is the rate of change of the area, and then the run is going to be your radius. So that's why the bottom is going to be your radius, okay? Next, C, find the average rate of change. Now, I want to highlight this because this is slightly different from the rate of change, okay? Average rate of change is back to the slope, which is going to be S2, or I don't want to use S2. I want to use Y2 minus Y1 all over X2 minus X1, which is your slope, right? Which is the average of change. But because we are dealing with area, we're going to say area of 10 minus area of 5 all over 10 minus 5. Well, area, I need to plug that back to the area formula. Area equals 2 pi, pi r square. Pi r square. So now I need to plug in what area of 10 is, right? When the radius is 10. So that means pi 10 square minus pi 5 square all over 5, okay? Well, that's going to be 100 pi minus 25 pi all over 5, which if we keep on going, that's going to be 75 pi all over 5. So if I were to simplify that, that's going to be 15 pi. Well, this is the average rate of change when the radius from 5 to 10 units. So what's the unit measurement here? It's going to be area units all over radius units. Okay, so as you can see, the derivative right at 10, okay, which is the instantaneous rate of when the radius is 5 and 10 on letter B, is different from the average rate of change. The average rate of change is really talking about the overall, right? If we were to take the average and add them all up and divide it by whatever 5 units in the bottom, then it's going to be 15 pi, okay, for every 1 unit of radius. Now the rate of change right at 10 or right at 5, as you can see, they are different, right? The rate of change at 5, the rate when the radius is 5, is 10 pi for each radius unit. And the rate of change, or the instantaneous rate of change when the radius is 10, is 20 pi. So it gets the rate of change gets bigger and bigger, as you can see, as the area increases. Okay, again, which is different from the average rate of change.